In this video, we will discuss the work done by the spring force. That is when any block or body which is attached with the spring, and when we stretch or compress the spring, it exerts the force on the block. So what is the work done by the spring force? So this is an example of work done by the varying force, that this force is not constant. It's vary over the interval of time. So this is the varying force. Okay, let's we have a body of mass of any block of mass m, and this is the block of mass m, and this one is the spring. So this block is attached with the spring, so whenever we stretch or compress the spring, it will exert the force on the block, and so the magnitude of this force we can represent it by Fs, that is the spring force, is equal to minus kx. So this here the x is the displacement, x is displacement, and k is called as the constant force, constant of force. So k is the constant of force. So x represents the displacement of block. Displacement of block from x is equal to 0, or it's from the equilibrium position. So here you can see that F as spring force is directly proportional to x. So it depends on the position, depends on the displacement from the equilibrium position. So when we remove the proportionality sign, it will be equal to Fs is equal to minus kx. So this equation is also called as Hooke's law. It is also called as Hooke's law. So this Hooke's law, as we know that it's valid only for a small displacement, only in or small displacement or in the limiting case of displacement, in which the cases in which the displacement is very small, so we can apply the Hooke's law. So what means by negative sign here? The negative sign means that negative sign signifies that force exerted by the spring is always directed towards opposite to the displacement. So this minus sign signifies that the force exerted by spring is always directed opposite to the displacement. If displacements in this direction, then the spring force will be in the opposite directions. And what about the k which is the spring constant? The k, it is value of the k is depends on the stiffness of the spring. If the spring is stiff, then spring constant has a large value. There will be the large value of k for the stiff string. But if spring is soft, it is of the soft material, then k value of k will be the small. So the value of k depends on the stiffness of spring. And Fs, that is the spring force, and spring force is always directed towards the equilibrium positions, that is also called as restoring force. So we can also say that Fs spring force is also called as restoring force. Why we call it the restoring force? Because we call it the restoring force because it's always directed towards the equilibrium position. So if it is the x is equal to 0, which is the normal position, which is also called as equilibrium position, and Fs spring force always tend towards the equilibrium position, so it is called as restoring force. As the work done always depends on the direction of force and displacement, so we can say that whenever the situation is like this one, so here this position, this is called as the normal position, x is equal to 0. Whenever x is equal to 0, that is when the block is in its normal position or in equilibrium position. Then for this one, Fs spring force will also be equal to 0. So this is called as the equilibrium position, and here we can draw equilibrium line. So this line pass through x is equal to 0. And secondly, if the situation is like this, that is when we stretch the spring. When we stretch the spring, that is when x is greater than 0. When x is greater than 0, then spring force will be directed toward the equilibrium position, which is x is equal to 0. So in this case, we can say that Fs, which is directed towards the left, so Fs is negative in this case. So it is in the negative direction. And while the position, and that is the axis, in this case x is greater than 0, so axis displacement is positive. So in this case, the force and displacement are in the opposite direction. And if the situation is like this one, so in this case here, when we compress the spring, so it means that now the x is less than 0. Here the displacement is negative, x is point in the negative direction, while Fs, which points toward the right, as we know that restoring force always tend towards the equilibrium position. So in this case, displacement is in this direction, and so the restoring force will point toward the equilibrium position. So Fs is to the right in the positive direction. So Fs will be positive when we compress the spring. So the direction of force and displacement is very important to analyze the work done by spring force. Now if we compress the spring, and bring it at maxima position, which is x is equal to minus, for example, if here the x is equal to minus x maximum. So if we bring the block in the negative maxima, in the maximum displacement towards left, and then we release it. If we release it, then it will definitely pass through x is equal to 0 or equilibrium position, and then will come to the other extreme position or other maximum, that is x is equal to x maximum. That is another position. Here we can draw it like this one. Okay, if this one is an equilibrium position, and here we have the block, so we have here x is equal to 0, x is equal to x maximum, and here we have the negative maxima, another maximum. So first we bring the block here, and if we release it, then definitely it will pass through x is equal to 0, and then come at x is equal to x maximum, and then it will go back towards x is equal to 0. And in the second case, if we stretch the spring, and if x is equal to x maximum is our initial position, xi, and if we release the block from here, and so suppose block has been, it will be pushed toward the left, it will pass through x is equal to 0, and then will go to x is equal to minus x maximum from equilibrium position. So it will move back and forth along the equilibrium position. So the total, so the work done by the block, let's suppose if we uh, release the block from left, if it is our initial position xi, if we release the block, from here, then the work, it is our initial position, then work done will be like this one, ws, that is work done by the spring, will be equal to xi to xf, and here spring force into dx. So it will be equal to here xi is equal to minus x maximum and xf is 0, and k spring force will be kx into dx. So it will be equal to ws will be equal to 1 by 2 k x square into x maximum. Okay, so in this case it means that now the work done is the positive, because force and displacement are here, the force and displacement are in the same direction. If work done is the positive, it means that force and displacement both are in the same direction. Okay, now the work done by the spring when xi is equal to 0, that is initial position is equal to 0, to xf, which is equal to x maximum. So in this case the work done by spring force, which will be equal to 0 to x maximum and fx into dx, and it will be equal to 0 to x maximum minus kx into dx. So it will be equal to minus 1 over 2 k x square maximum. So in this case the work done is negative. So negative work is done, so it means that F and D, force and displacement, are opposite. So both are in the opposite direction. So it means that net work done by spring force, net work done is equal to 0. Why? That is net work done from xi is equal to minus x maximum to xf is equal to plus x maximum. Xf is equal to minus x maximum, and this one xi is the plus x maximum. So the total work done for this will be F net, or F total work done will be equal to 1 by 2 kx square minus 1 by 2 kx square maximum here. So maximum, this will be equal to 0. Okay, now if the particle undergoes arbitrary displacement, then from xi to xf. If particle undergoes an arbitrary displacement, from xi to xf. Then in this case, uh, the work done ws, it will be equal to xi to xf toward the final position minus kx dx. So it will be equal to 1 by 2 k x I square minus 1 by 2 k x f square. Now the work done by applied force. Work done by applied force. On the spring. Work done by applied force on spring. So in this case, W applied, work done by applied force, it will be equal to if the force is applied on the spring. So in this case, from 0 to maximum, so F applied into dx, it will be equal to 0 to x maximum into kx dx. So it will be equal to 1 by 2 k x square. Here x is the x maximum, as F applied, which is the applied force on the spring, it is always like k minus k into minus kx, it will be equal to the kx. As we know that if this one is the spring, here the block is attached with the spring, and then if the spring force will be in this direction and we apply the force, applied force will be, as we have applied the force, we have stretched the spring uh, uh, in the opposite direction, so the applied force and displacement are in the same direction. So F applied is equal to minus into minus kx, it will be equal to plus kx. So work done by the applied force on spring will be positive, because force and displacement F and D displacement are in the same direction. Thanks for watching. For more videos, please subscribe our channel.